Okay, what is the question? Let us see it. Okay, few resistors, five resistors, okay, are connected in series and parallel connectivity. Okay, they are like this. Let me show you. They are like this. If I will show that they are two resistance R1 and R2 connected here in parallel to each other, right? And this is being supplied by a voltage source of 15 volt. This is given to you into the question, right? Now after this, it has been given that this circuit is coming like this, and here an ammeter is given to you. Ammeter is definitely used to measure the current, right? And here we have three resistances. Three resistances. Which are connected like this: 1, 2, and 3, right? And all three resistances are in parallel. So there are two pairing which is happening. Okay, one pair is the combination of R1 and R2 in parallel, and simultaneously this combination is connected in series with another parallel combination of R3, R4 and R5. Okay, and this is connected like this. Okay, so my dear friends, as you know, this is a voltage source, then definitely will current will flow from positive side, so the current will move like this. Okay, now what we need to find, we need to find the total resistance of this, total resistance of this circuit. Okay, this is the question. What is the total resistance? The first question is that total equivalent resistance is how much, right? This is part 1, and part 2 is how much of current flowing through the circuit. That means first we need to find R, then I, that means your current, total current is equal to how much. Both of this is a question mark to you. Okay, and the third part is that calculate the power dissipated in each of the resistors, right? The third part is that total power across R1, R2, R3, R4 and R5, right? Now from this is R5. I think it's visible properly. Yes. Now from here, what we do, the value of R1, R2, R3, R4 and R5 is given to you. And what are those values? The values, corresponding values are 5, 10, 15, 20 and 25 ohm, right? This is 5 ohm, 10 ohm, 15 ohm, then 20 ohm and 25 ohm. These are the 5 resistances given to you, right? Now from here, what we need to do, we need to find the total equivalent resistance. So the total equivalent resistance can be calculated when you just calculate the equivalent resistance of R1 and R2, right? And then calculate the equivalent resistance of R3, R4 and R5. Then combination of these two parallel, the first this part and thereafter this part. Okay. So this is part 1 and this is part 2. Right? This is part 2. If R1 and R2 is known to you, 5 and 10, then for the part 1, the equivalent resistance will be, you know, the formula for a parallel combination of two resistances, the equivalent resistance will be R1 into R2 by R1 plus R2, right? So the first part, this is first part, mind it, this one R1 and R2. This will be giving you the values. R1 and R2 is 5 and 10. So it will be 5 into 10 multiplied by 5 plus 10. So this will be giving you 50 by 15 ohm. So this is the R capital R I, we can say capital I, a Roman one, right? So this is the equivalent resistance of R1 and R2. Okay, this is 50 by 15 ohm. 50 by 15 ohm. This is calculated. Now come to the second part. This is the second part, okay, which I have encircled as R3, R4 and R5, right? For this, R2 1 divided by R2, right, equal to 1 by R3 plus 1 by R4 plus 1 by R5, right? You know it. So in this way, equivalent resistance of this combination of R3, R4 and R5 can be calculated very easily by putting up the values. Okay, what are the values? 1 by R3 is basically 15 ohm. So it will become 1 by 15. R4 is 20 ohm. So it will become 1 by 20. And R5 is 25 ohm. So it will become 1 by 25. Right? So when you solve it, you need to take the LCM of 15, 20 and 25. Right? So when you take the LCM of 15, 20 and 25, 5 3 15, 5 4 20, 5 5 25. Then anyone else? No. 5 3 15. So it will be 300 into the LCM, and into the numerator will be 15 into 20. So it will be 20 plus 20 into 15. So it will be 15 plus 25 into 12. It will be 12. So this will be giving you 47 by 300, right? 1 by R2. So R2 can be said as equal to 300 divided by 47, because this was into the multiplicative inverse. Okay, so 300 by 47 is the value of this combination, second combination, right? This is R2. R2 is coming as, this was R1. It's Roman 1 and 2. Don't confuse with this 1, 2. Okay. This is calculated as 300 by 47, right? So just write the value over here, 300 by 47. This much of ohm. Now students, our circuit will be simplified. Okay, how? It will be simplified like this. It will be simplified like this. A voltage source, then here R capital I, here R1 Roman, and here also it's R2, and here an source of current, or we can not source of current, it's a device to measure the current, that is an ammeter, right? So our circuit will be resolving like this. Our circuit will be resolving like this. Here 15 volt is the battery source. Our circuit will look like this. right? The above circuit will look like this. Now, if you find the equivalent resistance, we have almost reached to our answer, right? What is the answer? The equivalent resistance, because this R1 and R2, this R1 and R2 are connected in series, right? So equivalent resistance can be calculated as R Roman 1 plus R Roman 2, right? And what is the value of R1? R Roman 1, the equivalent for the first. That way you have calculated 50 by 15, right? See this value, 50 by 15. So just put up this value over here. So this will be equal to 50 by 15 plus R2. R2 is calculated as 300 by 47. This is the equivalent resistance of R3, R4, R5. This is 300 by 47. So just add it. It's a simple calculation. You can do it, and this you can say this is the equivalent resistance. So in this way we have calculated the first part, total equivalent resistance. That is 50 by 15 plus 300 by 47. Okay. This is the total equivalent resistance. Now, since we have calculated the total equivalent resistance, and we know that by Ohm's law we know that voltage is proportional to current, and when we remove the proportionality constant, R will be multiplied to it, right? V equal to IR, and V is given to you as 15 volt. I is not known to you, that will be acting as a variable, and equivalent resistance we have calculated, that is 50 by 15 plus 300 by 47. Okay, so in this way we calculate I is calculated. So first we calculated R1 over here, then we calculated R2 over here, right? This is R1 50 by 15, and this is R2, right? And when we add it, we will get the equivalent resistance here. R equivalent equal to R1 plus R2. These are Roman 1 and 2. I should have used A and B instead. Okay. So when we add it, we get the R equivalent. And when we put the R equivalent into the Ohm's law, we will get the current, right? The current is will be equal to 15 volt divided by 50 by 15 plus 347, right? This entire will be going to the LHS into the denominator, right? So it will be equal to 50 by 15 plus 300 by 47, right? So this will be this much of ampere will be your current. This much ampere will be your current, right? You got the steps. What I did, these two resistances in parallel, these three in parallel, I find the R Roman 1 equivalent for this. Similarly, R2 for this, right? Then our circuit simplified like this, right? Simplified like this. And this is the simplified version of the circuit. Our circuit will be looking like this now. R1, that is the equivalent for the two resistances in parallel, and R2, that is equivalent for these three resistances in parallel. And here 15 volt will be as it is, applied the Ohm's law, we get the current as equal to 15 divided by this much of ampere. I'm not going into the calculations, my dear friend. I'm just showing you the steps, right? Now, when we calculate the I, right? We know the voltage across a parallel connected circuits are always equal, right? Voltage across a parallel connected circuits are always equal. So if this is terminal A and this is terminal B, right, then voltage across A and B will be equal to how much? The R1, the equivalent resistance 50 by 15, right, this equivalent resistance multiplied with the current flowing through it. What is the current? This current is the same current which is measured by the ammeter over here and whose value we have calculated. Just multiply this current with the equivalent resistance of R and R2, that is R capital I, which is equal to 50 by 15. Then you will get the voltage across A and B. You will get the voltage across AB here. When you get the voltage across AB, right? When you get the voltage across AB, same voltage will be between through R1 and through R2, right? So if the same voltage through R1 and same voltage through R2, and we are knowing the value of R1, then definitely the current through R1 can be calculated, right? Isn't it? Or the power of R1 can be calculated. Simple. Need not to go into the current. If you calculate the voltage, then power equal to V square by R. So for R1, if I will calculate, let us say the calculation of power through R1. Power through R1 equal to V1 square by R1, right? This will be equal to V1 square by R1. Is it visible? What is V? V, that means voltage across A and B, and that is calculated by this current multiplied with this R1. So our current is 15 divided by 50 by 15 plus 300 by 47, right? This is the current, right? This current multiplied with R1, this one, equivalent resistance of R1 and R2, which is 50 by 15, we have calculated, you can see here. So just multiplied it with 50 by 15. No, V square divided by R1, not multiplied, divided by R1, and a square the voltage I into R equivalent will give you the voltage. This will give you the voltage. This will give you the voltage. And this voltage, when you put up into this formula, you will get V1, right? Then V1 square by R1 will be the power for the resistance 1, right? That will be equal to V1 square. That means this value, whatever you are getting, divided by R1, and R1 is nothing but 5 ohm, right? This should be the power across resistance R1. Now, power across R2 will follow the same voltage, right? So this voltage, right, V1, so power across R2 will be equal to this V1 square, as happened in for resistance 1, power across R1 is V1 square by 5, right? Similarly, power across R2 is also the same voltage. Here it's V1 across terminal A and B. It's equal to V2 square divided by R2. What is R2? R2 is 10 ohm. You can say here, divided by 10. So in this way, you will get the power across second resistance. Similarly, we know R2. R2 is the equivalent resistance for these three. This is R2. This is R2, right? Now, when you just multiply, find the voltage 2, V2. V2 is calculated when you multiplied I with R2. This Roman 2, mind it, right? Now, I is calculated, this one. So just put up the value I as 15 by 50 by 15 plus 300 by 47, right? This is your I. This is your I. I multiplied with R2. What is the value of R2? 300 by 47. 300 by 47. So this will give you the value of V2, right? So you will get the voltage across these 2 points. This is nothing but V2, right? And when you get the voltage across V2, the same voltage V2 will be across R3, same V2 across R4, same V2 across R5, right? Now, when you get the V2, then what we will find? Power, power across R3 resistance will be equal to V2 square by R3, and R3 is nothing but 15 ohm. You can see here R3 is nothing but 15. When you solve it, you get the answer. Okay, this much of watt power. This is power, right? Similarly, power across R4, this resistance R4 will be equal to same voltage, because same V2 will be across R3, R4 and R5, which we have calculated here, V2. So this will be calculated as V2 square divided by R4. R4 whose value is equal to nothing but 20 ohm, right? This will give you power across R4, resistance 4, R4 whose value is 20 ohm. So V2 square by R4, this much of wattage, this much of wattage is the watt for power across R4 resistance, right? Similarly, power across R5. What is R5? R5 is nothing but 25 ohm, right? So just write here V2 square, which we have calculated here, V2. Mind it, this is V2. V2. I into R2, right? So this will be V2 square divided by the value of R5, which is equal to nothing but 25. This much of watt is your answer for power across the resistance 5. Power across the resistance 5, R5, right? So in this way, students, we have solved all the part of this question. Just I tried to keep all the things on the single page, right? So that's why it becomes little tedious, but I think you can get the steps very easily. Let me quickly revise within a minute. These two resistance in parallel. Let me show you. These two resistances in parallel. Okay. So that's why what we did, we find the equivalent resistance. Similarly, these three in parallel, we find the equivalent resistance. Now, the circuit will be simplified like this. Now, these R1 and R2 are in series. Just add it and we find the equivalent resistance of the entire circuit, right? Now, from here, the voltage is 15 volt, that is known to you. So, 15 volt, apply Ohm's law, equal to I into R equivalent, and I is calculated like this: 15 divided by 50 by 15 plus 300 by 47, right? This much of ampere is the value of current, right? I'm not going into the calculations, right? When you find the current, this will be equal to, here I am writing it, 15 divided by 50 by 15 plus 300 by 47. I am repeating it, 300 by 47. This much of ampere, right, is your current. This is your current which we have calculated, right? Now, if this current is calculated, this, let me show you, this is like this, okay? This is the same current. Now, if you find the current, then just you find the equivalent resistance of R1 and R2, which we have calculated R capital I, Roman 1, right? With R Roman 1, what we did, we calculated the voltage V1, right? That is I into R Roman 1. Here you can see. Or V, this is V1 is nothing but I into R1. Okay? This will be multiplied, right? This will give you V1, right? Now, power equal to V1 square by R1. Just put up this value of V1 over here. So this will be V1 square by R1. So whatever the value of V1 we are getting from here, just put up over here V1 square. That will be the voltage across A and B, this one, right? And the same voltage will be across R1 and will be across R2, because this is a parallel connected circuit. You see it, R1 and R2 are connected in parallel, right? So that's why what we did, when we calculated this with the same current with this R1 by applying the Ohm's law, this I and this R1, we get the voltage V1, right? And when we get the voltage V1, just V square by R1 will be giving you power across the resistance 1. Similarly, what will be the resistance across R2? This will be again V1 square by 10. So I should not like this. It's V1 square across here, then definitely V1 square across R1 and R2 both are same. Both are V1, right? I'm writing it here, V1, right? So that's why just keep it as V1, same nomenclature. This will help you. V1 square by 10. And this is the value of V1 which we have calculated, right? I into R equivalent, right? So this will give you power across resistance R2. Similarly, V2 is calculated. V2, that means voltage across R3 and R4 and R5. That is calculated. Just use the equivalent resistance R capital 2. Here, this one. Now, this is R2, this Roman 2. With this, multiply the current. You can see, you will get the V2. You will get the V2 over here. You can see here, right? With this V2, with this V2, this is the V2, this is the V2, right? With this V2, power across R3 will be calculated V square by R. So V2 square by 15. V2 square by 15 will be the power across resistance R3, and V2 square by the value of resistance 4, that is 20 ohm, will give you the power across R4, and this V2 square divided by R5, which is equal to 25 ohm, this will give you the power across R5. So in this way you can see, for all these three resistances R3, R4 and R5, we calculated the PR3, PR4 and PR5 respective powers, right? So in this way, I think we need to close the session for today, and I hope it's understandable to you, my dear friends. If any query, any doubt, just put up into the comment box, and I will be get back to you. Okay, and thank you so much for watching. Be connected. See you. I will come up with next session with some different concept, some new concept with for better understanding. We'll discuss on the same. Okay. Thank you so much for watching. Take care. Bye bye. See you, my dear friend. Be connected. See you. Bye bye.